Hello, everyone. Welcome to the first registered report session of the ESEM conference. This is a session where people submit planned studies and we review them, and there'll be some short presentations here. So the presentations will be 5 minutes, and then there'll be time for a question or two after that. So with that, I want to go ahead and get us started. So let's bring in the first speaker who's going to talk about their registered report on to VR or not to VR. Is virtual reality suitable to understand software development metrics? And I'll let David go ahead and get started.
Okay. Hello, everyone. First of all, thanks to the organizer and the program committee for organizing this ESEM. I'm David Moreno, and I would like to present you our registered report. To VR or not to VR, is virtual reality suitable to understand software development metrics? Well, mainly, software engineers interact with code by using a keyboard and a mouse, using a 2D monitor. And this way of interacting does not take advantage of the many benefits of human movements and perception. For example, the natural gestures of turning the head and leaning, etc. However, this is not the case with the virtual reality, since the environment is immersive in 3D and these natural movements can occur. In addition, in recent years, affordable VR devices have appeared and new standards have appeared as well, such as WebGL and WebXR, which allow the use of 3D and VR in open and universal technologies, in this case web technologies, which can be viewed in any modern browser. In fact, in the specific case of software engineering, some scholars argue that the use of VR allows for an environment that may make practitioners face lower learning curves, be more creative, and achieve higher productivity. Hence, in this report, we propose a controlled experiment for the comparative evaluation of two approaches to the data visualization versus VR immersive visualization of data about software development, being the main aim of testing if VR immersion is at least as effective and efficient and on-screen 2D for the visualization of the same data. And the field of analysis for our experiment will be the pull request activity. It is a major interest in industry and practitioners, as it is very human intensive and often the cause of bottlenecks and inefficiencies. And with the help of Remote Lab, Bitergia gathers and enriches software development data to create a set of pre-existing dashboards. In particular, there are some dashboards that show several aspects of the pull request process. And this is an example of the Bitergia dashboard shown in Kibana in a 2D environment. And this will be the 2D setting for the experiment to be carried out. And for the VR immersion setting, we will use Babia XR for the development of VR visualization, providing a scene where the visualizations will be organized. And this is an example of the possible environment that we will show to carry out the experiment with Babia, but well, it is just to be defined. So the main goal of the experiment is to analyze if the comprehension of software development processes, in particular modern code review, pull request, via the visualization of their metrics is better when presented in VR scenes than in 2D screens. Regarding the experiment itself, we will have at least 30 participants from academia and industry with experience in different relevant topics about software development. We will present the two environments to each participant. The first one presented will be randomly selected, and then they will answer a set of tasks. The data presented will be data related to code review per request about two software development projects, one per environment, with similar characteristics for a fair comparison. And the task will be the same for all participants, but each question will be presented to each subject randomly only in one of the two settings, and one for the two projects. Kibana works in any modern browser, so for the on-screen part of the experiment, we will use a normal computer, and for the VR virtual reality phase, we will use the Oculus Quest 2 VR glasses. The experimental, we offer the participant these glasses to carry out the experiment, but if the participant has glasses of the same model, they can use them as well with the computer. Regarding the task, we will define them with the help of Bitergia and its experience in analysis of software development projects. Focusing on the main research question of our study is comprehension of software development processes via the visualization of their metrics better when presented in VR scene than in 2D screens. And we divide it in two, one for the accuracy and one for the efficiency. The variables are detailed in the register report, and we will follow the ECM 6 empirical standards for the experimental design. And well, for determining the behavior, we will use statistical analysis for the completion time of the task, and we will measure the significant difference for the best metric according to the sample size of the participants. To finish, summarizing the execution plan, first, to avoid bias due to the previous experience, we will run a training for the participants for Kibana and VR dashboards, and then a demographic form will be used to control the subjects confounding variables. Then we will present the first environment, randomly selected, with half of the tasks, randomly selected as well. And when finished, we will present the second environment with the rest of the tasks. To finish the experiment, we will present a feedback form for possible improvements or problems that the participant faced, and so on. And once the experiment has been carried out, we will analyze the possible deviation that would have occurred in its development. And the testability of the experiment are detailed as well in the report. And that's everything. Thank you very much for attending this talk, and let's see if there is any question.
All right, thank you for your talk. So far, I don't see any questions in the chat, so I'll go ahead and ask one. What do you see as the biggest challenge to successfully completing this study?
Okay, I think the biggest challenge is to have a huge amount of participants. No, I think that the biggest challenge is we are that the VR immersion in several ways to visualize data is better than use to the monitor. I think that the best challenge is to prove that this is useful in terms of software development metrics, because the immersion in VR is I would say that is almost infinite. So you don't have a wall. You can move around the scenario, and I think that the main challenge is to prove that it's better in some ways.
Okay, great. Well, I see no other questions in the chat, so thank you for your presentation, and
Thank you very much.
let's move on to the second one.
Okay, thank you.
So our next presentation will be on gender bias in remote pair programming, the twincode exploratory study, and Amador, we can bring him in to present. And just to remind those of you that are watching, if you have any questions or comments, please put them in the YouTube chat, and I'll be able to ask those at the end of the talk. So I'll turn it over to Amador now to begin his presentation.
Okay, so thank you, and good morning or good afternoon to everyone. Since I only have 5 minutes, I'm going to go right to the point. So first of all, what is the motivation of our research? Well, we want more women in our software engineering courses at our universities. And, pair programming seems to help, as reported in previous research. But gender bias and negative stereotypes about women as developers don't. So our general research question is whether gender bias affects remote pair programming among centennial software engineering students. I mean, centennial because they're students born after 2000. I mean, at least 2 generations older than me. And why remote pair programming instead of collocated pair programming? Well, among other reasons that I have no time to explain, because in our experimental design, we need our students to believe that their partners change between tasks, but they actually remain the same to reduce variability. So to achieve our goal, we have developed the twincode platform, in which students can do pair programming by sharing a source code editor window where they can execute their programs and also communicate using a chat in a message window. Depending on whether a student is in the experimental or control group, they see gendered avatars of their partners to make them believe they're working with a man or a woman. As you can see in the slides, this is someone from the control group, someone from the experimental group, okay? Well, with respect to our experimental setup, we first allocate subjects to groups, but we try to preserve gender proportion because we don't want all of the few women we have to be in the same group. Then students are also instructed to remain anonymous during all the study, neither revealing nor asking for personal information. Then students are randomly allocated into control experimental pairs. So the students coming from the control group do not receive any kind of information about their partner's gender, and the students coming from the experimental group are going to see gender avatars and other information about the gender of their partner. So we want them to believe that they're working with a man or a woman, independently of the actual gender of their partner. After that, they have to perform several tasks. The first one is a pair programming task in which they have to work together to solve some programming exercises. In this first task, students from the experimental group see randomly gender avatars. Then they have to fill out a questionnaire about pair programming productivity compared to solo programming, and about their partner's technical competency compared to their own. After that, they have to perform a solo programming task whose only purpose is that the students forget about their first partners, so they do not recognize them in the following task. Then they have to perform another pre-programming task, similar in difficulty to the first task, but in which the gender avatar is swapped for the students in the experimental group. That is, it changes from man to woman or vice versa. Finally, they have to fill out 2 more questionnaires. Questionnaire number 2 is the same as number 1, but referred to the second partner, whereas questionnaire number 3 contains questions comparing both partners. After all that process, we end up with 37 response variables. 3 variables are computed from the 3 questionnaires, which have 25 questions in total. 5 variables are automatically collected by the twincode platform, which is the one you have in the slides. And 30 variables are elaborated by the manual tagging of the chat messages using the tags you can see in the table on the slide. The tagging shall be performed by at least 2 researchers and checked for inter-rater agreement. With respect to the data analysis, we're going to analyze the deltas, the differences of each response variable to detect differences between the experimental and control groups that would be theoretically caused by the gender bias factor. Apart from the difference between groups, we also plan to analyze the experimental group data only for detecting differences when a partner is perceived as a man or as a woman. And also, we also want to investigate if there's some interaction between the perceived partner's genders and subject's gender. That is, if men and women scored differently other men and women. Thanks to the reviewers, we're also going to analyze other aspects that you can see in the slide, but I have no time to comment. And finally, our plan is to run the baseline experiment next month at Seville, and going to Berkeley for the first replication, and performing another replication at Ecuador if possible, with your under negotiation. In the case we can perform these 3 experiments, we will also analyze data for cultural differences among the 3 locations. And well, that's all I can tell in 5 minutes.
All right, great. Thank you. Sounds like an interesting study. I don't see any questions in the chat yet, so I'll ask one quick question. So on your experimental design in the task 3, when you say that the gender of the partner, or at least the gender of the avatar, is changed, is that the actual gender of the person they're working with, or is it just random? People do not actually know who they're
ideally, in the first task, students in the experimental group see a random avatar. It doesn't have nothing to do with the actual gender of their partner, and then it's swapped in the third task. So if they work supposedly with a man in task 1, they're going to work with a woman in task 3, and the opposite.
Okay, but it's not the actual gender. It's just a
no.
Yeah.
Well, in the pilot we use the actual gender, but there's a problem. There's a lot of we have much more men than women,
right?
So it causes a bias in the results, because we don't know if results are due to most of them are men or to any other factor,
So one more question. We have another minute. I don't see any other ones in the chat, so I'll ask one more. Do you expect to see differences in your results depending on the gender of the subject, not the avatar, but the gender of the person that's actually participating in your study?
Well, it's difficult to foresee, especially because I have mentioned during the presentation, we're working with people that was born in 2000, 2001. So their cultural reference are quite different from mine. I was born in 1970, so I don't know, honestly. That's why it's a registered report, because we don't know what we're going to find, So I cannot pronounce myself about that.
All right, good. Well, thank you. That finishes the time for the questions, and we'll move on to our third paper. So thank you for the presentation, Amador. The third paper is adopting automated bug assignment in practice, and we can bring the presenter in, Markus Borg. And so I will turn it over to you. And remember, if you have questions or comments, please put them in the chat so that we can ask them at the end of the presentation. So over to you, Markus.
Thank you, Jeff. My name is Markus Borg. I'm with RISE, Research Institutes of Sweden. I'm presenting this registered report about an evaluation of a bug assignment tool that we deployed at Ericsson a few years ago, based on the paper you see on the screen. And now we want to see if it actually provided any value. So this work is a collaboration with Ericsson, Leif, Jonsson, the lead inventor, and Bela and Attila, the current maintainers of the tool, and Lund University through Emelie Engstrom. And I don't know if you got a chance to watch Max's keynote a few days ago. So he questioned there the practical significance of very minor tool improvements and called for more qualitative analysis. And this work responds to that call, I think. And what I think is really cool with this project also is how it illustrates successful transfer of research ideas to industrial practice. So such activities take time. The first related paper was published by Leif in ICST 2012, the testing conference. And by that time, Leif had already experimented with machine learning for a while. This was then becoming very trendy among the data miners and the MSR community, for example. And the year after, Leif presented his ideas at the ICSI doctoral symposium. And there in San Francisco, I met Leif and joined the project, and we worked hard then on evaluating the concepts in two companies and published the paper you see here in MC. And then in 2017, the concept was turned into an internal Ericsson tool. And the year after, Leif got his PhD. And in 2019, the tool did its very first assignment of a bug without any human intervention whatsoever. So this was an important milestone. And now it's been in operation for 2.5 years, and we are about to evaluate it now. And this is what this registered report is about. A quick illustration of the tool. There is this bug tracking system, and the bug reports within Ericsson are called trouble reports, and they originate in different parts of the organization. And in the standard way of working, TR coordinators, humans, they pull reports from the bug tracking system and then assign them, push them to development teams. And sometimes they are reassigned, the phenomenon we know as bug tossing. And the tool TRR can be seen as this plugin that contains a machine learning model that predicts which team should resolve an incoming bug report. And if the prediction has a confidence level above a certain threshold, the bug is then automatically pushed to a team. And this is how we see the study. The context is engineering at Ericsson. And the case under study is automated bug assignment using this tool. And then we study 4 units of analysis. So we have the maintainers of the tool, the TRR team. We have the engineers working as TR coordinators. And then we have 2 development teams. One that uses fully automatic bug assignments today, and one that opted out of full automation and only uses the predictions as decision support, as a comment that is attached to a specific bug in the issue tracker. And here's a simplified GQM illustration of what we plan to do. Our goal is to evaluate this tool within Ericsson. We have 4 research questions. The first one is about how the tool evolved from research prototype to deployed tool. The second one is how accurate the tool output is. And this is the standard analysis you tend to see in papers. And then we have a third one about how much value the tool actually introduced in the organization, if any. And then fourth, how has the tool influenced the way of working? And we will use a mixed method approach here. So quantitatively, we look at tool output, descriptive statistics, and we will try to do a Bayesian causal analysis, as was also used by the Nobel laureates in economic sciences, announced this Monday, actually. So that's going to be interesting. And qualitatively, we'll run interviews then and We'll analyze the interviews using the quality performance model, the technology acceptance model, and Parasurman et al.'s types and levels of human interaction with automation. And this was my final slide, so thank you for listening.
All right, thank you. Sounds like an interesting study. Again, we don't have no comments or no questions showing up in the stream, so maybe I'll ask you the same question I asked the first paper. What do you see as one of the biggest challenges to having a successful study, especially doing this with the industrial setting?
Yeah, that always adds uncertainties, of course. I mean, getting access to the right people. People are busy. People have other things to do in industry, strangely enough. So this, I guess, is the major challenge. And then, yeah, there will be some statistical modeling, and the Bayesian stuff will be interesting. And new to me, it's the second author that's going to drive that thing. So for me, that's going to be a challenge, I think.
All right. Thank you. I see no other questions, so look forward to seeing an interesting study. So thank you, Markus.
Thank you.
All right. And now we can move on to our final paper in the session. The last paper is which design decisions in AI-enabled mobile applications contribute to greener AI? And Roger is here to present, so I will turn it over to him.
All right, so thank you, Jeff. So hello, everyone. My name is Roger Creus, and I'm now going to present our registered report in which we describe a protocol for an empirical study in which we will study which design decisions in AI-enabled mobile applications contribute to greener AI. So this research work, we have done it together with Professor Silverio Martínez and Xavier Frank from the Polytechnic University of Catalonia. So to start, I'll make clear our understanding of this red versus green AI dilemma. So by green AI, we understand these environmental friendly solutions, AI-based solutions. And in contrast, in red AI, we see this perspective of problem solving with AI components that only looks at improving the accuracy without taking into account any other thing or disregarding all the other costs, as for example, the computational resources or the complexity of the solution and so on. So with this, our objective is to systematically investigate the accuracy and complexity of these AI solutions. And in particular, we will look only at AI-enabled mobile applications. So we choose here the accuracy and the complexity as representative metrics for measuring this dilemma of red versus green AI. And we also, our objective is also to find and to reason about this sweet spot of achieving high accuracy systems while maintaining their complexity at low levels. And then our methodology consists in planning confirmatory empirical studies. So we will identify some variables and craft some hypotheses, and then we will provide our experimentation and hypothesis testing in order to give results and conclusions. So we will basically be developing a set of AI-enabled mobile applications, and we will be providing experiences during the software engineering of this. And with all this, our goal is to analyze the impact of some design decisions that will happen over the software engineering lifecycle and relate them with respect to some green characteristics. And again, here, our objective or goal is to reason about that sweet spot of high accuracy systems with low resource consumption. So here in our first research questions, on the left, we see the ones that the variables that we identify as representative of the performance. So we see the accuracy, the memory usage, and the storage weight. And the idea of this is that these allow us to reason about the accuracy and complexity of a system. For example, if we've got two different applications that integrate AI components, and one is a bit less accurate than the other one, but still is much more efficient in terms of memory usage and storage weight, we could reason that the second one contributes to better to green AI and might be more useful if we take into account these complexity constraints. And then we relate these performance metrics, which are the dependent variables of our study, with respect to our design decisions that we identify as the number of parameters of the AI models and their architecture type and their data set. So arguably, these are the very important design decisions when thinking of an AI component. So for instance, imagine that we're facing an image-based problem. So we want to solve it. So first we think of an architecture to use. So should we rather use a convolutional neural network or a ResNet or any other architecture? So imagine we fix a convolutional neural network. So that's a design decision right there. And then, okay, how many layers and how many parameters or how deep should I design these networks? So that's the second design decision there. And finally, we take into account the data set as to measure whether the quality and quantity of the data that we use for training these AI models actually has an impact in the performance-related metrics on the left. And then we have another additional research question in which we provide our empirical evaluation of profiling tools that are the ones that we will be using for collecting the performance-related data and analyzing and reasoning about the performance of the AI-enabled applications that we will be building and developing. So finally, here we summarize our plan. So we will be solving image classification problems on 3 different data sets and text classification problems also in 3 different data sets. Then we will be developing a wide range of different neural networks, going from convolutional neural networks to recurrent ones and to transformers. Then we will be using different technologies like PyTorch and TensorFlow for developing the AI components and deploying these to Android Studio and Unity, and eventually using and operating with these AI-enabled mobile applications in Android devices. And we will then profile their performance and give answers to our research questions, both in the relations between the design decisions that we have found during all this life cycle and the application performance, and also relating to the profiler validity. So that would be pretty much it. So thank you very much.
All right, good. Thank you. So no questions in the chat. So I'll ask one question: is what do you hope to be the outcome? What do you see as a positive outcome at the end of the study? I know you don't know what the answer will be, but what would you like to see at the end of the study?
So what would be nice here is to evaluate the quality of an AI model, not only taking into account the accuracy that it achieves. So this is the most common tendency, right? We just keep the model that performs better on some data and that solves our problem better. But specifically when targeting mobile devices, we also have to put the focus on the user experience on that. So maybe a model is very accurate, but uses so many resources that the user experience inside a mobile device can be very rough. So maybe we can learn a way to reason about and to prefer a model or an application that maybe is a bit less accurate than the state of the art or the best model, but is much more efficient and can provide much better user experience in the edge devices. And we want to find as an outcome a way to reason about these differences in these mobile applications.
Okay, great. Well, thank you for the interesting presentation, Roger. And thanks to all the authors for participating in the first registered report session for ESEM. Hopefully we'll see this in the future. And thank you again, and look forward to seeing you in the sessions tomorrow. That'll finish this session.